Hi guys. So in this project, we will be building an MLP classifier model that is to be trained on a song dataset to predict if the song will be popular or not. So for the dataset also, we are going to use the Spotify API to get information about different kinds of data. That could be the song information from your playlist, that could be the song information from the Billboard playlist, right? There are different kinds of playlists that Spotify also creates. So you can take that data and use it, or I would say shape it into a data set and feed that to your MLP classifier model to see if a song will be popular or not. We will then prepare our very own website that will be built using the Django framework and hosted on Google Cloud. So let's get started. So I'm going to go through the contents of the project, which includes introduction, building the model, creating our Django project, hosting on Google Cloud using the Google App Engine. So introduction. Now, as I told you, in this project, we will be building the MLP classifier model that is trained on songs dataset to predict if the song is popular or not. Unlike other classification algorithms like support vectors or naive Bayes, MLP classifier relies on an underlying neural network to perform the task of classification. Then we will prepare our website using the Django framework and host it on Google Cloud. Now building the model. Now MLP classifier stands for multi-layer perceptron classifier, which in the name itself connects to a neural network structure, right? The advantage of using MLP classifier is that it is very efficient, puts less strain on the hardware, and gives off accuracy which is close to what I would say to a deep learning model, right, in comparison. The only difference is that unlike the traditional deep learning models, MLP classifier doesn't have a backpropagation structure. It only performs feed forward process and tries to learn in that process only. Okay. Now creating the Django project. So Django is a free and open source web application framework written in Python. It includes advanced functionalities like authentication support, management and admin panels, contact forms, which is basically handling front-end data and sending that to the backend. We have file upload support and more. So in other words, if you were to create a website from scratch, you would need to develop these components by yourself. But by using this framework instead, these components are already built in, and what you have to do is just configure them or call the already built classes or functions to match your site. Then we have the last part, that is hosting on Google Cloud. As you can see, I have written it as the last stage of the process of building the project, where we will host the newly made website using the Django platform with the help of Google Cloud. This is a little, I would say, uh, misinformation, right? We would be actually using the platform, Django platform, to create the website, but we would be hosting it on Google Cloud using the Google App Engine, right? So with this, when we have understood and hosted our website, we would be able to access our website and run the model from anywhere across the internet. So let's move forward to the first part, that was developing our model, right? The MLP classifier. So this is the first part. I would say this is the prelude for the first part. That is because this is where we're going to understand how to use the Spotify API with the help of developer Spotify, and then try to create our data set. And after that, we would actually move on to creating and developing our model, the MLP classifier. Right. So Spotify keeps a lot of data on its songs internally, and that we can access through the Spotify API. The Spotify API is a great public tool allowing the use of Spotify's wealth of music data to build many kinds of system. And one of the many kinds is the classifier we are going to build. So the first thing you can do is go to this link that I provided here, right? Just go to that link. Once you, yeah, so it would provide you the developer Spotify page, onto which you can see there are a lot of different, I would say, different options to go to discover, understand more about the developer. Spotify for developers. Then we have the docs. Here in the docs, we have the general category, we have the web API, which is what we are going to use, right? Then they also provide a web playback SDK. This is more advanced stuff. Then this is for your apps. And we have our, yeah, this is for apps. So we are going to use the web API. And if you want to see what exactly the developer provides you, what different functionalities that you can use, you can start with the quick start to understand the overview. Then you can go into the references. If I click on references and we move forward to here, you can see that we are now in the reference part, and here you can see if you want to access the albums, what you can do in it. Get albums, that is the data for albums, right? If you want to even create a Python script which is removing albums or saving albums, then there's the option for that. If you want to get the data for artists, if you want to get the data for shows, setting, deleting, updating shows, right? Okay, not exactly updating because that is something that Spotify would do, not you. But yeah, when we talk about deleting or saving or liking, right, all of that can be done through a separate Python script with the help of these APIs, or I would say the endpoints for these APIs. Right. Now, the thing is, if you want to just move forward to see what exactly we are going to do, then just click on dashboard, right? So on dashboard, it would ask you to log in. Okay. And yeah, here you can see it is asking for me to log in. So once you log in, so once you log in, it would ask you to create an app, or it would list out all the apps that you have created. So you can click on create an app. Then you just need to type in app name, maybe the description, click on this and create the app. So once you create the app, your app would be showcased here. Or if it is not showing, just refresh the page and then you would be able to see that. Then click on to the app, right? Click onto the app and now you can see, okay, I'm gonna tell you what this is exactly in a moment. So the main thing to notice here is your app status, okay, then your client ID, and then your client secret. So client ID and client secret are the most important thing right now for us, okay. So you can get your client ID and client secret saved in a separate file, because this is what we would require to use the APIs that Spotify provides us. Now, these both of these are required to authenticate with the Spotify web API for our application, and can be thought as a kind of username and password for the application so that we are able to access the data Spotify has for us. Okay. It is best practice to not share these, right? Especially the client secret ID. But for this project's purposes, I can show you this because most probably I would be deleting this app once the project is completed. Okay. And the next thing is to see the daily active users. So basically, since nobody has the client ID and client secret for this app except me, so the only access active user would be me. And while developing this project, I was developing during these dates. So you can see there's a high user activity here, which is basically one, that is me. But you can see the monthly active users this month, one user. If you're using the same I would say client ID and client secret, then it would show me two. If two people are using, then it would turn out to be three, and so on, right? Then okay, number of users per country. Wow, it is not showing India while I'm in India. Anyways, so these are some of the stuff that you can go forward and look into, but the main thing was to create the app and get the client ID and client secret. So moving back to our script, the next thing to do is install Spotify, which is the package which helps us in creating objects where we can store the data retrieved from the endpoint, right? So install this. Then we have the import. Okay, so this is basically importing the Spotify and the authentications. Okay, Then what we are doing is we are creating SP, that is an object of Spotify. And before that we are basically authenticating that yeah, we are an, you have validated to be, we are a validated user and we can use your APIs. So for that, just type in the ID and the client secret, again not to be shown to anyone else, but I'm just showing this. Okay. And then we have the Spotify, calling the Spotify class, sending in the client credentials manager, right, and creating the Spotify object. Now, once you have created the Spotify object, the next thing to do is, okay, there are a lot of things to do, but what exactly I am doing right now is getting data from a certain playlist. Okay, if I just, kind of open this in my browser, right? So you can see that this playlist is by me, right? This is my own playlist. I've just named that as EDM. Okay, so you can see that there are a lot of songs here. Okay, there are a lot of songs right here. So Spotify has different URLs for each of the songs, for each of the albums, for each of the playlists, right? All of the podcasts, they have different different URLs. So what you do is you just get that URL, right? Then you get the particular URI. Okay. So the thing is, this thing right here that you can see is the URI. Now this is unique for each object created in your Spotify app. Okay, so what we are doing is getting this unique URI through the split function, taking the last part right here, right, because the last part is my URI for this playlist. If you go on to this link that I have provided, if you want to go here, so this was, I think, the Billboard playlist. Yeah, no, don't open. Yeah, you can see that the top songs global playlist is this one, and the URI for this playlist is this, right? So next thing that you can see is I'm taking out the playlist URIs for each and every track. Now this URI was to specify the playlist, and these URI that you can see is specifying each and every song's URI, right? I had, I think, 800 900 songs in my playlist, so each URI is now inside my list. Okay, then yeah, so you can see that I am getting, so the thing is, this track URIs will is a JSON format, or I would say in a dictionary format, and it has multiple keys. So I'm getting the items key and seeing what value it has, exactly what type of value it has. So it is having a list, right? So if I get the keys from my list, okay, this might be confusing. So basically the thing is, I have a dictionary, right? My uh, okay, so my object is calling playlist tracks. Inside that, it is taking the playlist URI and asking for retrieve the items that are stored by Spotify. So it is storing the I would say the information in a list, right? Now if you see that inside this item list, we also have another dictionary which again has a lot of keys in it, and you can see that there's an added by is local, primary color, track, video, thumbnail. So for a particular song, when was it added at in the Spotify? Who added it? Is it a local song, international song? Then there's a primary color, I don't know about that, but then there's a track. So information about this particular song is inside this. Then we have the video thumbnail. Now, yeah. So see, if I'm trying to access what all information is inside the track, I'm uh, I'm making an object of this, then getting the track information. So you can see there's an album, Then inside that album, there's another dictionary which is showcasing the album type, single, the artist. It has a list, and you can see that there's some URLs too. So these are defining the artist. If I just click on that, you can see that it is again redirecting me to Martin Garrix, again an artist. So the artist information is also stored. Then the link for that, the ID of the artist. You can see the name, the type. Then we have a lot of information here, right? So I'm just going to retrieve the important ones, which you can see here. So I've just used a for loop. Inside that, I'm getting all the information inside the items key, right? Because this already was a list which was storing a lot of information. Then I'm taking the URI, I'm taking the track name, I'm taking the artist, I'm taking the artist and his or her popularity, the genre, then the album name, then the popularity of the track itself. And you can see that the name of the song is Won't Let You Go. And then we have the Spotify artist and his ID. Then we have his name. Then we have his popularity. It is out of 100. And somehow okay, so the album name was also Won't Let You Go. And then the track popularity again from 100, right? So this is for all the songs that I have right now, right? In my playlist. Yeah, okay. Then you can see that except for the above information, if I want to have the, I would say, the audio information of a particular track, right? I can even have that. So let's take the first song, right? The first song was Won't Let You Go. So I have the different kinds of information right here, but I want to get the audio information for this particular song, right? So for that, we use the audio features. We input the URI for the track. Then you can see there's the acousticness analysis URL. You can click and go on that this particular API. So most probably it won't show you much, but hitting this API would return back some information, right? Then we have danceability, duration. This is in milliseconds. Okay. Then we have the energy, instrumentalness, key. Again, not so important right now, but liveliness. Then you can see a lot of different audio information for this particular track, right? So what I've done is I've created two data frames for now. One is storing the audio information. One is storing the different information about the, I would say, uh, yeah, the artist, his popularity, her popularity, name, genres. Then we have the album, track popularity, artist popularity in a different, in a different data frame. Then the last thing I'm doing is I have concatenated both of my data frames and got a data set for me. Again, this is not exactly the final data set. That is because a lot of information like the IDs, then if I move forward, there are a lot of API, right? So I have to remove this, then I have the analysis URL. And the most important thing, I still don't have my feature where I would say the classes if the song is popular or not. So that would have to be done manually, right? And that was a very lengthy process, but yeah, it has to be done manually. Okay, so this is how you can create your data set using the Spotify API and through the developer Spotify. Then you can see that last thing I'm doing is finally, saving my dataset into a CSV file through the to underscore CSV function, giving the parameter as the path where I want to save, and this is the name of my dataset. Right. So with this, we have completed the part where we are going to create the dataset by ourselves using the Spotify API. In the next part, we would be developing our model and then training our model on the self-built Spotify dataset. So for this project, I have already in this project, right? We have now understood how we can create our own dataset using the Spotify API. Now the next thing to do is actually develop our MLP classifier model and train it onto the said dataset, right? Now, yeah, the first block that you can see is a block that is helping us mount our drive onto our Google Collaboratory, which basically means that uh, you don't have the access of the folders and files in your drive directly with your collab. So you have to run this block, which is importing the drive function from the google.collab and using another function mount, which is taking the content drive path and telling collaboratory that you can now access the anything inside this drive folder, right? Okay, so I also, yeah, I've written sing in. Yeah, nice. Not sign in. Anyways, you know what this URL has, right? We have covered that in the last part. Then we have some of the libraries that we are going to use in this project to develop our model. So the first we can see is the pandas in the NumPy library, right? So NumPy, which stands for Numerical Python, is a library consisting of multi-dimensional array objects and a collection of routines for processing those arrays. Now using NumPy, mathematical and logical operations on arrays can be performed, and they can be performed at a very efficient and fast manner, right? Then we have the pandas library, which is a Python package providing fast, flexible, and expressive data structures designed to make working with relational type of data or with time series data very easy. And with the help of pandas, we can manipulate the data, store the data, extract information from it in a very easy manner because they provide a lot of functions that help us in getting those key inputs from my data, right? So these are very important libraries. Then we have the Seaborn and Matplot library. Both of these libraries are used for embedding plots into your application, right? Using, I would say, general purpose GUI toolkits like Tkinter or GTK. Again, in essence, they just provide you with the ability of creating plots, right? So that you can infer more about your data through it. Then we have the sklearn library, right? We have the sklearn library. Now, scikit-learn, again sklearn, is a free machine learning library for Python. It features various algorithms like support vector machine, random forest, k-neighbors, etc. And we will be using the MLP classifier that this library provides, right? You can see I've imported that through the neural network inside the sklearn. Then I'm importing the metrics and the train test split function to create my training and testing data. Right, so this is the data set that I have created before, right? And now you can see that it still has some information that we would be removing. But you can see that most of the important information is present inside here, right? And you can see that I've created the class variable 0 or 1. Okay, so that is that. And using the head function, yeah, using the head function, I'm printing out the first five data points from my data set. So here it takes in a parameter here, and by default it is 5. You can type in 10, then first 10 rows would be showcased here. Okay. Then we have the df.shape, that is data frame.shape. So it is telling me that I have 10,001 data points with 23 columns in it, and in which one is our predicting class, right? So using the isNull sum function, so isNull provides me with true and false, where true is the case in which it finds a null value present inside a particular column, and then the sum is the number of times true has occurred. So you can see that artist familiarity has 4 null values in 10,001 columns, sorry, rows, and we have 6,000, 4,000, 6,000, 4,000, and one null value for these specific columns. So I'm going to drop those which have a lot of null values in it because I don't want to insert or fill them, because this would I would say this would create less randomness in the data, or I would say this would um, populate the dataset with values which might not make the model properly understand the information that it should have. Okay, so I'm dropping these, you can see, and some of these are actually just information which would not help my model. Then I'm filling up the null values in those where the number of null values are pretty less. Okay, so I'm using the, as you can see, fill any function, right? And I'm filling it with the mean values and the median values, right? You can, use mean in both or median in both and see if it's, helping your model understand better or not. But for now, I filled them with mean and median. Now, just to validate, I get that, yeah, there's no null value now in my dataset. So the next thing is, yeah, so with the help of value counts, you are able to see the number of time unique values have come in your dataset. So in my class column, there are two unique data, that is 0 and 1, and 0 has come 8,809 times and 1 has come 1,192 times, right? So this is how you can see what all unique values are present inside your column if your column is too big, right? And you can see how many times each of these unique value have occurred. Then I'm creating some graphs just to see the distribution in different features that I have, or if I need to, pre-process them or do some kind of feature engineering to get them in a more usable format. So when we talk about, there are different kinds of processes like normalization and standardization. So these are actually terms which are names of different processes which helps us in shaping the data in a way that my model is able to, get most information out of my data. So we have a bell curve, right? The bell curve is the curve of a data set which shows perfect normal distribution of my data. So that is the best data that you can feed to your model. So there are different ways where you can create a normal curve out of a skewed graph or a skewed curve, right? So we can see that we are getting a bell kind of structure here, though we are getting two peaks, which is not the best case, right? Then I have a better bell curve structure right here for duration. But the thing is, this is skewed. So your data should be in the middle with the median, right? With the mean, sorry, with the mean. And it should be evenly spread. So that is not the case. Similarly for start of fade out, end of fade in, this is a really bad one. And we have a mode confidence which is showing a bell curve. There's a small peak here, but yeah, this is good. Then this is the worst because they're showing two peaks and they are pretty, widespread. So nope, that is bad. Again, two peaks, not so good, right? But this was to showcase what exactly your data has, and if you can even pre-process the data into a better format, and once you would fit that data into your model, you would see a high, increase in your accuracy or in your F1 score, right? So next is I'm dropping artist ID 2 and my class column, because that is going to be sent to the Y. I would say the, different uh, different variable, right? Because I want to have my features and my dependent variable differently. Okay, so that is that. Then again, dropping some of the information that I might not require, because having a lot of columns creates a complex model, right? And again, it takes more time to train. It creates a bigger model that would be, taking more RAM once you're using your virtual machines, right, in Google Cloud. So this is my final data set that I have, and this is just to showcase all the columns that it have, the name of the columns in a list. Yeah, okay. Then I'm just using the train test split to get my testing and training data. I've taken the test size as 0.3. Then we have instantiated an MLP classifier. Now I would be stopping right here, and in the next video I would be talking about how MLP classifiers work and what exactly are the parameters and how do you create those parameters, or what do you insert in those parameters, right? To learn more about the MLP classifier, so how exactly is it working, what's happening under the hood, then we will talk about the parameters that we input into the classifier, right? And lastly, we will find out the quality of our classifier, the accuracy for it, and how do you realize if your model is really working well or not. Okay, so the first thing to know about the MLP classifier is that we have, so as I told you, the ML, okay, not off to a great start, but the MLP classifier, right? The MLP classifier we have is a neural model, right? Is a neural model. And so, what exactly does the neural model have, right? It has some layers in it, right? We have some layers in it. Then we have our output layer. So, we feed data into these layers, and these layers, the data hops on, goes to the output layer, goes back, goes back, goes back, goes back, then again moves forward, again moves forward, again moves forward, again moves forward, then goes back again. And this whole process happens like this till we reach the number of epochs, right? The number of epochs we have. Let's say we had epochs is equal to 5, right? 5. Then we will have this one, then we will have this back propagation, feed forward again, back propagation, feed forward again, back propagation for 5 number of times, right? And the lastly we will get some weights, right? Weights from our model, and then we will learn that yeah, we have our we have our function, right? We have our function with us, right? We have our function with us, which is predicting the output for us, right? Which is predicting the output for us. So this is how a neural model or neural net architecture works. So as I told you before, MLP classifier does not have a back propagation happening. So what happens here is that I have my first layer right here. It has some neurons in it, right? We have some neurons in it. Then I have my second layer here. It again has some number of neurons in it. Then I have my third layer, my fourth layer, and so on till I get my last layer, the output layer. Let's call it O. Or let's call it out. This is my input layer, the first layer. And these are my hidden layers. Okay. The hidden layers. Okay, this is not the best in writing. I can show you, but you would just have to bear with me on this. Right, so we input the data here, then these neurons have certain bias and weight, right? So we have certain bias and weight for each of these neurons. Then we have the same thing for this layer, for this layer, for this layer, till we reach the output layer, right? So what happens here is that when we are moving in the left to right direction, right? When we are moving like this, then we are having our input data be multiplied by a function which is using bias and weights to get me an output. Let's say for this point, I'm having f1 function with me, which takes in my data, which takes in my bias and weight to give me some output. Okay. So once I get the output, that output becomes the input for this layer, right? And then at this point, let's say that function f2 is working, which is taking the output 1, then bias 1, then weight 1. Okay, then I'm getting the output 2, right? So at this point, I'm getting the output 2, which is becoming the input for this layer. So this is how we transform our input data to reach the last layer where I get my final output, which becomes my prediction. Okay. So what happens in traditional model is that once I get my final output here, this output is matched with the actual value I had, right? Let's say the y was 0 for this, right? Was 0 for this. And my output was actually y hat is equal to 1. So I say that, oh, the actual value was 0, but I got 1. So this means that our model is not performing good. So what happens here is that we start with the back propagation where we start updating the bias and weight. So we start changing the bias and weight so that in the next iteration when I move forward and reach my input layer and again start the process of forward propagation. So I have my new bias and weights with me, and then I again start transforming my input data to my to reach my output value, and then I see if my y prediction is now 0 or 1. If it is 0, then that means that we have changed the weight and bias in such a manner that it is now predicting accurately, right? If it is again 1, then we say that, oh, the bias and weights which we changed in the back propagation process right here is not uh, as bad as something that we want. So we again start with the back propagation and again start changing the bias and weight to see if the next time we have our feed forward process, if we are getting the value 0 or not. So we do this for uh, each data and see if we are predicting right or wrong. So this is how the model is able to, you know, uh, is able to update or upgrade itself to get me better accuracy, right? Get me better accuracy. So this is how an MLP classifier is working. So what happens is that we stop the back propagation process and we only have the feed forward model, and the ways we change bias and the weight is different. Okay. So this is how we are working with the MLP classifier, and with the thing is that since we have already removed the back propagation process, the model is now faster, right? The training time is less. That is because the back propagation, right? We have the feed forward, feed forward. Okay, man, this looks bad, but yeah, feed forward, and then we have the back propagation, right? Back propagation. So this takes some time, let's say T1. This takes some time, let's say T2. So we have already eliminated that. So in each epoch, we are only going forward with the this process, right? So we are only working with T1 right here. So this way, our model is becoming more faster. It's learning faster, right? The only downside, I would say, that we are not having the back propagation with us, so the method of updating the bias and weights are different, and it is not as accurate as the deep learning models, I would say. But yeah, in terms of getting better, I would say lesser time, right? Getting lesser time and requiring, I would say, less powerful, right? Less powerful hardware on you. MLP classifiers are very good to work with if you want something that has a neural network structure, but you don't want to use a lot of time to just train the model, or you don't have enough hardware to, you know, I would say sustain the model. Right. Now coming back to the model, you can see that there's parameters like hidden layer sizes, max iteration, activation, solver, and random state that you might already know about. So hidden layer sizes, in this parameter, we can specify the number of layers and the number of nodes we want to have in the neural net classifier, right? So basically we have the number of nodes and the number of layers. Each element in the tuple represents the number of nodes at the ith position, where I is the index of the tuple. Thus, the length of the tuple indicates the total number of hidden layers in the neural network, right? So I have three hidden layers with me, right? And in each layer, the first layer has 200 neurons, the second has 150 neurons, and the last one has 50 neurons. Then we have the max iteration. Again, this is the number of epochs, basically number of cycles the process will go on to update my bias and weights to get a better accurate model. Then we have the activation function. Again, this is a function which is required for transforming the data while creating a threshold, right, for us in the model. So we're using the ReLU function. There's a leaky ReLU, there's sigmoid, there are different kind of functions for different purposes, right? Then we have the solver. Now the solver, this specifies the algorithm for weight optimization in your nodes, right? So we're using item. So these are some of the layer, sorry, some of the sorry, some of the parameters that you can input in the MLP classifiers to instantiate your model. Then using the fit function, giving the input as my training data with the feature and the dependent variable. Then you can use the inbuilt function of score, right, to see what your score would be, basically what your accuracy is for the model. And you can see that there's 0.879, which is near to 0.88, which is 88% accuracy. And then we can also go for and see if the model is predicting good for the test also, for the test data too. And you can see that the value is 0.884, that is 88.4%. Again, for this project, I would say that this is a good enough accuracy. But if you want, you can make changes in the pre-processing part, right? You can make changes in these part where you are normalizing your data, right? So you get a bell curve, or what you can do is even create, maybe use some of the columns that I have removed, right, to get a more complex data that is able to predict at a better accuracy, right? Then we have the classification report, which gives you precision, recall, F1 scores, right? And you can see that the precision for each classes, the recall, the F1 scores for them, right? Then you can just take the weighted average for all of, if you have multiple categories in your prediction classes, right? Then the another thing that you can see is plotting. If you want to plot the loss curve for your MLP classifier, you can do that by the loss curve function that you can take in the values from the model, right? You have your model dot loss curve, and you can just plot that, and you can see that we started off with around 1, and we went to nearly 0.4 after 35 epochs. So you can see that we have taken max iteration as 200, but after 35 we can see that we have reached an all-time low and it won't be going anywhere below that. So we could have stopped at, 50 or even 40, right? So we didn't have to go to till 200. So this is why you can, get a loss curve to see what exactly is happening inside the model, how well it is performing, right? You could even create a different validation data set and plot the validation curve too. Then the last thing we are doing is just saving my file, right? Saving my model into a pickle file with the help of pickle package. And I'm using the function dump. Then the first parameter is my model itself, and the second parameter is where I'm opening the place where I want to save my model, right? So it's inside some directory named music popularity model dot pickle. Right. So with this, we have completed the first part, right? We have completed the first part. We were developing the model. So we've got our data set. We have used that data set, input into the model, and finally trained our model. And the last thing we did was save the model so that I am later able to use it when we are creating our Django project. So see you. Hi guys. So with this video, we're going to start the building of our website using the Django framework. Okay. So let's understand what Django is. Now, Django is a free and open source web application framework written in Python. And a framework is nothing more than a collection of modules that makes development easier. They are grouped together and allow you to create applications or websites from an existing source instead from scratch. So this is how websites, even simple ones designed by a single person, can still include advanced functionalities like authentication support, admin panels, retrieving, storing data, file upload system, and more. In other words, if you were to create a website from scratch, you would need to develop these components by yourself. But by using Django, you can already get a pre-built existing source code project onto which you can write codes to, add on functionalities that you want to have. Now, Django has a template views architectural system, right? Model template views architectural system that keeps in mind the requirements of front-end and database management for a developer. So we will see this architecture, what exactly does it mean and how it makes things easier for a developer. Moving forward, let's first see how to instantiate a Django project. Now note, you don't have to run all of these steps, or you don't have to go through all of these steps, right? So these steps are showcased here for two, I would say two situations. One where you want to just use the existing code base that I will provide, or you want to create your own Django project and then want to, configure that project, right? So let's start off if you were to create your own Django project and you want to configure that. So how do you do that, right? Create a virtual environment. That's the first thing you should do, right? If you're using PyCharm like me, you can just click to file, then you can just go to settings. There's a pop-up that's going to open, and in that pop-up, go to the project. Inside project, click on project interpreter. Then you can see there's a project interpreter here, but let's say it is not showing for you. You can just click on that settings button and click on add. Now you can just go to the new environment, set up the space where you want to store your virtual environment, and then the base interpreter would be shown here. Okay, so I'm using the Python 3.7.6 version, right? And you can just click on OK. Now since it's already stored, the environment location directory is not empty. It is not letting me create one because I already have one running there. Okay, then after that it would start instantiating some stuff. After it's completed, you can just click on apply here, then click on OK, right? And just open your terminal again and you can see that your your code base would be having a virtual machine running, having a virtual environment running, not virtual machine. Okay, so that's the first thing to do. The next thing to do is install Django, right? Just write pip install Django and any version you want, let's say 3.2, 3.6, something like that. Right, I'm just using 3.2 version right now. Then once you have done that, you have to run this command to create your actual project, right? So Django admin, start project, name of the project. Now I named it as my site. So you can see that this directory right here was created. Then inside that you would see that a my site directory is also created. And inside that you would see files like ASGI, settings, URLs, VSGI, right? So these are configurational files. These files are instantiated, and these files, you can write codes in these files to configure how exactly your Django project should work or should, behave, right? So that's that. Then the next thing to do is get the requirements.txt file from my code and store it inside the this directory, this my site directory here. Okay. Then cd into the my site directory in your terminal and run the command pip install -r requirements.txt. So this will create, okay, this will actually install all the dependencies, all the packages that are required to run this project or run your project in general, smoothly. Then we have, yeah, so then the next thing to do is create an app. Now there's a difference between a project and an app. So the project is I would say the app is like a subset of a project, where project is a Django website and apps are different functionalities that you have added to your website. As you can see, this is my MySite project. It has another folder that is my site having all the configurational files. Then I have polls, which was my app. So I had written Python manage.py start app, then polls in my terminal and I hit enter. So I got this polls created here, which again has files, but these are different files. You can see views, test, apps, models. So we, okay, not exactly, you don't have to do anything here. So what we do is we create different apps. We write in code to add on new functionalities onto our project, which we want on our website. So we do that through apps. Then once you have also created app, the next thing to do is set your settings.py file, right? Configure your Django project, how exactly is going to work. So I would come on to this part later. Okay. Now, if you were to just use the existing code base, what you need to do is just again first create a virtual environment, then open up your terminal and get into the my site directory here. Then all you have to do is run this command, right? Again, to install all the dependencies and packages. Then the next thing to do is directly run this command here, python manage.py migrate. So this is a Django specific command, okay? And the migrate, what this does is that it instantiates all the tables that might be required by Django or that you have created inside Django to be instantiated in the database, right, that you're using. Now, Django provides you an SQLite 3 database by default, but you can use external applications like MySQL or Postgres and connect them to your Django application. So what this migrate will do is that in your database system, let's say MySQL, it would create all the tables that Django requires or you have created there, right? Or else what you would have to do is that again go to MySQL and start creating those tables, then try to connect them here. So it is auto handled by Django. So this is the last command which starts a local server on your machine. And again, I would come to this later. So now that you have understood what are the steps, let's go to settings.py file. Like how exactly do we configure the Django project through here? Okay. So you can see that we have a different kind of variables set up here. We have base directory, we have secret key, debug, allowed host, installed apps, right? So we have debug, which is set to true right now, which helps us in understanding if a code is creating some kind of problem, or if we haven't written correct code, then it would tell you that there's an error and it would show you the traceback for that error. Then we have secret key, which is unique to each Django project. And with the help of that, if somebody has the access to this key, they are able to do certain things which you might not want. Okay, they can handle stuff in the Django project even if they don't have the access to the code. Then we have allowed host, which means that what all connections or what all machines can connect to your Django application. Then we have installed apps. You can see that they're pre-built apps. Then this is the app that I created. So Django already has pre-built apps in it which are handling a lot of functionalities for us. So we don't have to, code from scratch to get those functionalities. We have the admin side, the admin panel. We have the authentication that is handled by Django. We have the sessions, right? Then we created polls, which was our own app, to add on some functionalities which Django doesn't require. Sorry, doesn't provide, right? Like running my machine learning model or deep learning model or OpenCV model, right? Then we have our middlewares. So Django also handles middlewares. We have the security middleware, session middleware, CSRF view middlewares. Right, again, you don't have to write anything from scratch. They have already pre-built this stuff. You can maybe append something in them, update them, or just simply configure them to work as you want on your website, right? Then we have the templates. So templates is a Django jargon which basically means that you are talking about the front end, you're talking about all the files that you serve to a user when he hits a particular URL, right? That is what we call templates here. Then we have the database, so you can also set up your database. So if you want to connect to an external application, you would type in the name, you would type in the user, the password, on which host or on which port it's going to work, right? So that is again handled through settings.py file in the database variable. Again, this is a dictionary here. Then we have other variables to handling other stuff in Django. These were the most important ones that I have specified today in this video. Okay, then the last thing I'm going to talk about in this video is the .env package. So the thing is that if you have sensitive data on your machine in the code that you don't want anyone else to access, even if they have the access to your code, so you can do this by creating a .env file. So as you can see, I have a .env file with me, which is holding the Django key, which is my secret key, and the IP address. This is the IP address of my VM. Okay. So I don't want somebody to access this, even if they get my code somehow. So what I can do is I can create a .env file, and through that file I can call these values and set them in my specified variables. So when you create a .env file, what happens is that this .env package has a load.env function. So once you run your code, all of the data here gets stored as system variables in your system, and then load.env calls that those system variables get those values through here, right, through this os.environment.get, and store that value in the particular variables right here, right, as you can see here. So this is how, if somebody again has the access to your code, all he would be able to or she would be able to see is this, right? So that person has to get into your system variables too to get these values right here. Now the thing is, once you run your code, all of the .env file data gets stored as system variables. You can then delete the .env file too, so that nobody is able to get your data from here, right? So you can delete that too, and the code would be running perfectly. So I think I've completed whatever I wanted in this video. In the next video, I would talk about the model template views architectural system, right? Which is also very important to understand, because that in in that explanation you would be able to see how the application is performing, the handling of databases, the handling of front end, and the handling of back end and the data itself. Okay. So see you in the next video. Hi guys. So in the second part, We are now going to talk about the model template views architectural system and how does that make things easier for us when we are working with Django framework. Now, as you can see, we're going to work through the apps, and in that I have the templates folder which has the index.html page. So we have our front end with us, then we have the views and we have the models, right? So if I open models, you can see that it's asking me to create your models here and importing django.db import models. Again, db means database. So the thing is, you create your models, which is nothing but tables here. You tell Django that in these tables, these are the columns that I want to add. What data type would they store, right? And if they have some constraints on them, then what are they? So everything is, set here. And then you can just call these models in your views, right? You can call these models in your views, like you can write from dot models import table number one. Then if you have some data that you want to store in them, you can just do that inside a function. So this is how you're able to store any kind of data that you get from the front end or you generate in the back end to your models. And when you store something in your model, it and Django automatically takes that data, sends it to the database system that you're using or you have configured in your settings.py and asks that external applications to store this data in itself. Okay, so that is how models views is working, and somebody is able to handle his or her database system through Django only. Next thing is talking about the templates or our front end. Now, obviously, I must have a front end so that I can retrieve information from the user. So I've created an index.html page which has uh, instyling and inline style too, right? So you can see that I have my CSS part right here. Then I've created a form. You can see that it has a method post. Then you can see that I'm using the CSRF token to validate the form. Then I'm taking input from my user, right? So all of that has input. Then they have unique name. And I will tell you why they should be unique. Then I have my submit button so that once a user clicks on submit, all of data that is sent through the user is then retrieved in the backend. So the thing is, once a user hits the submit button, I have a function which is taking all the values, right? That was input by the user, right? I'm storing them in my variables I've created here, right? So the thing is, we create functions in the views.py file, right? We create functions, and these functions are mapped to specific pages on the front end part, right? So what happens is that once you hit a particular URL, you are served a page, and that page is mapped to a function, so you can get the data from that front end to the mapped function in the back end, and you can manipulate the data or get results from the data and send back the result again to that mapped front end page. Okay, so you can see here that I have a return, right? I have a return for this particular function, which again takes in the output of the render function. Now the render function takes a parameter of request, then index.html and my response. So basically it is taking the output of whatever the render function is returning, and the render function is taking what page is to be rendered. And if you already have some kind of data that you want to showcase to the user from the backend, you can send that in a dictionary which is called context. So this is how the backend function is mapped to a front end page. But you can see that I did create the function, right? I have also created a predict function, but there is no call for this function, right? You can see I've just instantiated, created, defined what the function is doing, also have my returns, but there's no call for the function. So to call the functions, we have a separate file which is the urls.py. Now in this particular file, we map on which URL what function is to run, right? Basically, what happens in Django is that you go to a particular URL. Let's say that we go to the URL something something slash home slash, right? We on the browser go to the something something slash home slash URL. Then Django understands that, oh, this particular URL was hit, so we have to run the handler function here. So the handler function is called. Then in views it understands that, oh, I have to call the handler function. Then in the handler function, it sees if a user has input some data or not. If it has, then I can get all my data from the post dictionary into my particular variables. Then what I'm doing is creating a data frame out of that, and then I'm sending that data frame to my predict function. In the predict function, it is sending that data into the predict function of the model, right? This is our MLP model, MLP classifier model, right? I'm getting the results, so I'm just printing that result and returning that result back. So I get my result right here. So since I've got my result, I'm sending that in the context part through a dictionary, right? So in the key, now I have the result. So this response or this context is again sent back to my front end, that is the index.html page. And here I'm showcasing I'm showcasing my values here, what my result will be. Okay. So you can see that if the response is 0, then the song is popular. No, it is not. If the response is 1, yeah, the song is popular. Yes, it is. Right. Else, this means that no data was actually sent to us because there's no class 0, no class 1, or we had some kind of error. So that would just tell me that submit the data again or something. Okay. So this is how exactly the Django website would be working. You hit a particular URL, that URL calls a particular function, that particular function renders a particular page, right? And then all of the data that you send through the front end is handled. If you want to send back some result, that is sent through the context dictionary, right? So right now, in terms of model views template architectural system, we are only using the views and templates. That is because we are not trying to store or retrieve data from anywhere in terms of databases, right? So that is why we haven't used models anywhere. But you can use models if you want to, though really not necessary. So this is how the website is working. Now let's talk about the model. You can see that I'm importing the model from a sustain file, right? Moving to the sustain file, you can see that there's a django.core.cache import cache. So what I've done is that I've created a cache system too inside the website. Now what happens is that if you were to just directly call your model in the predict function, let's say, right, you just pickle.load the model. The thing is, every time, sorry, every time you refresh your page, the URL is hit again and the handler function is called again. So each time you refresh, the predict function here would be called again and again. Then the model would be loaded again and again here. So that is not a really good practice to do. That is because uh, the model takes time to load, right? So each time you reload, the model is loaded again in the backend, and that takes time. So your refresh rate is, I would say, the refresh time is very high, which is not good for a website, right? You don't want to have a site which is loading, taking a lot of time just to get refreshed. So what we do is we create a cache system where we store the model itself, right? So what happens is that once you run your project for the first time, a cache key is created which is mapped to your actual model, right? You can see that I have loaded the model here in the model variable right here. I've just set the cache. So what happens is that for the first time you run the project, it will take some time to create the cache space for your model to be stored there, right? It would then create a cache key too for it. Then each and every time you maybe, let's say, refresh the page and the URL is hit again and again and the function is called again and again. So in the predict function, when it is called, the model would already be loaded, so it would just call it here. It won't load again and again because the model is directly called from the cache. So that makes the refresh time less as compared to before, which is also good for you because when the model is loaded, your CPU usage, spikes again and again. So you don't want that too. So yeah, so we also covered the cache system that we have created for the Django application, right? Now the last thing is to run your project to see if it is working fine and all the functionalities are working as expected to. So run the command python manage.py run server. Okay. So once you run this, for some people it might also show that you haven't, run a uh, migratory command to that I might have missed. So I would run that too. But as you can see here, it takes some time to, perform system checks to see if everything is fine and all. If it is not, then it would tell you the errors in the command line only. Right. So just one command to run before this is the migrate command. Okay. So I did talk about the migrate command, but I did never run this thing. So yeah, you can see that seeing it is trying to see in all the uh, apps if there are some changes in the models and you want to transfer those changes into the said application that you're using for your databases. So it checks for that, and if there's no changes it would tell you no migrations to apply. Then run the same command as before, that is the run server, to instantiate a local server on your machine, and that would run your project and you can see if it is working fine or not. And this is a user warning, usually happens when there's a little conflict between the versions, right, in the sklearn and the versions you have used to build your model. Nothing serious. Click on the link. It would open it in your browser. Yeah, here you can see that there's a page not found here. That is because we haven't mapped any particular function onto this URL. We have mapped it to a slash home URL, right? So you can see I have my predict words right here. So if I type in any value, right? Okay, I should have written what I'm inputting in these in this input fields. And this is just numbers right now. What you can do is just in the placeholder, you can type in what values we are trying to, if this is the loudness or the danceability or something. So just input values here, click on submit, and here you can see that will the song be popular or not? The answer is no, it won't be. Right, so with this we can see that our model is also mounted, it is working properly, and our website is running. So I think we have completed the second part also, that was building our Django application. And with this, I would stop this video too. And in the next video, we would start with how to host our website onto Google Cloud using the Google App Engine. Okay, so I'm just going to stop my server right now and see you in the next video. Hi guys. So in this video, we're going to start with the hosting process. That is, we're going to create a virtual machine instance on our Google Cloud. We're going to configure how to make one, and finally start with transferring the files, that is our code base, from our local machine to our virtual machine and setting that up on the virtual machine. Now for hosting the website that we have developed, we will be using Google Cloud Services, and particularly the Linux VM they provide, which are scalable computing capacity in the Google Cloud. Using them eliminates the need to invest in hardware and all that you probably already know. But the thing is, why they are so popular is because they provide you with a lot of different types of virtual machines, their capabilities, right? Which is helping you to, rather than invest on creating your own hardware, you can just use the hardware, right, on a monthly basis and host your websites and make changes in them, manage them, and stuff like that. Now, Google Cloud VMs provide some of the following features that you should know about, right? So when I say virtual machines or cloud machines, they are just instances which are basically virtual computing environments that Google Cloud provides to you. They are they have pre-configured templates in your instance, right, which are known as machine images. Now these instances are different from, sorry, these templates are different from the Django templates one, because these instances have templates which are actually the package or the bits that you require on your server to run the virtual machine properly, like the operating system it should have or any additional software that it should have, right? So that is what encompasses the templates in the machine, in the instance, right, which are known as images or machine images. Now, as I told you, we are provided with various configurations of CPU, memory, storage, network capacity on your instance, right? And they are categorized into different instances. There are different types, right? Then they provide you a way of having a secure login, right? They provide you information like key pairs, which are used as a username password to log in into or to SSH into your VM. They also provide you with temporary data storage, with permanent data storage, and they have different capacities in them, right? For your instances, you can directly connect, disconnect them. Then they also provide you with a firewall that enables you to specify protocols, maybe ports or IP ranges that can reach your instance using security groups, which we would be moving forward with later in this video. They also provide you with IPv4 addresses, right, for dynamic cloud computing. These are known as elastic IP addresses. You might have seen something similar in AWS or Azure too, right? Though in terms of similarity, I think Azure and AWS are kind of similar, but Google Cloud works in a different lane altogether. So let's start with the process of creating a virtual machine, okay, on the Google Cloud. So the first thing you would be able to see after you log in into your Google Cloud account and are redirected to the Google Cloud platform, which is just the dashboard. So the thing is, you can create certain projects, right? As you can see, I have my first project right here created for me. So I only have one project right now, right? But you can create new projects, and in those projects, you can create virtual machines that you can use to host your website. Now I've already created one, but just to show how exactly you move forward with creating a virtual machine, the first thing is to go to compute engine, then go to virtual machine instance, right? So there's an option to create the instance, and we would be moving forward with that. I can see I've already created one, right? And it is running right now. The instance is running. But we're going to create a new one here. So there would be a create instance option. Click on this. It's going to redirect you to the page where you're going to configure your VM, right? Now you have to type in the instance name. Let's say music popularity 2, right? We have the music popularity 2, and then the region, right? You have the region here, which is, for me, I'm gonna set it to this, right? You can pick up any zone. I'm gonna let it be the default one. Then we have the machine type. Which kind of virtual machine do you want? Should it be a general purpose one? Should it be a compute optimized, memory optimized, right? I'm gonna go with general purpose one only. So it's showing me the monthly estimate too, right? And you can see that I have some free credits to use, and this would be cut from my free credit till I have them, or till my time expires on Google Cloud, right? Then we have the series, this EC2, N2, N1, right? So I'm going to move with EC2 only. Then we have the machine type. We have EC2 medium, which has two vCPUs and 4 GB of memory. Now they also show you if you want to have CPU plus GPU, or if you want to just go with GPU, then what type of. So if I click on here, you can see there are a lot of uh, a lot of options for you. I'm gonna go with T2 Micro, which gives you two vCPUs with 1 GB of memory, right? Because our instance would be hosting our website, but the website is not so heavy that you would require, additional powerful hardware. Then we have some other tools that you can, help in configuring your VM. Then if you're using Docker, creating a Docker image for your code, then you might want to go with deployed container. Then we have the boot disk, which is having a size of 10 GB. Now you can see that the image present here is Debian, right? Which is a support, I would say, which is, yeah, Linux. Okay, so we have a Linux set here, which is and having the OS Debian, but I want to change that, right? I want to have maybe, let's say, a Windows one, or I want to have, let's say, Ubuntu. So what I would do is in the operating system, I would see for Ubuntu. You can see we have different kinds of OS right here, right? Now I have my Ubuntu, I have my Windows too. So I'm going to go with Ubuntu. Then it would tell me what versions of Ubuntu they have, which is 18.04, 20.04, 21, and minimals. Okay. So I'm going to go with 20.04 LTS. Right. So if you want to increase the size, you think that 10 GB might not be enough. I want more. You can just type in, let's say, 100,000, anything. I'm going to go with 10. And then the boot disk type. So we have the persistent disk, we have the SSD persistent disk. So let me tell you, SSD would be working faster than your balanced, than your standard ones, right? So if you want, powerful hardware in terms of disk, you can go for the SSD one. You just click select here. There's advanced configuration too, but if you are not, if you're starting with Google Cloud, I would suggest let it be the default values there. Okay. So then we have the identity and API access, let it be as it is. Now in the firewall, allow HTTP and HTTPS both. Okay. Now let me tell you, S is for secure, HTTP might not be secure, but this is what, on this your website would be working for now. Okay, then we have additional configurational, settings for us, which is the networking. If you click on this, you would see there's a network tag, maybe host name. If you want to have a custom host name for your instance, right? So I won't have it. And then if you want some additional performance gains on your network and you want to configure that, then that is for this. You can keep, or you can, let it be default. Then we have disk if you want to add an additional disk, right? So we already have a 10 GB persistent disk with us, balanced persistent disk with us. But if you think you need additional one, you can add a new disk. Or if you think that I have already created one disk and I want to use that particular disk here only, so attach an existing disk, right? There's an option. Okay, there's no option for this. Then we have the secure. Yeah. So the thing is, now while we create our instance, right, to log in into our instance, we would require a particular SSH key, which is something like a password, right, to log in into your VM. Now you can see that there's the option of add items. So click on this, you can enter a public SSH key to create your password for this particular VM. So I'm going to tell you how we can create this in just a minute. But this is very important to know that SSH keys, without SSH keys, you won't be having any chance of logging in into your VM through your local machine or through any machine for that matter. So you need to have that, or you need to create that if you don't have it, right? So Okay, so now let's move forward and see how exactly do we create a, SSH key. Okay, so what you have to do is go to your project directory wherever you have put your project, right? So I have my project in here, right? Music popularity. Just you know, just ignore these files because we're going to create a new one for us. So what you have to do is you have to open the CMD, right? In your terminal, you have to run a particular command that is SSH key gen, right? We're creating a SSH key. Then, okay, so it's asking for the name in which you want to save the SSH key. So I would say that this is music popularity 2. I want to save it in that. Enter a passphrase. So if you want to, have a really secure key, so you can even create a password for your password that is your secure key, right? Like, but I don't want to have any password for that. So I've just created one, right? So the thing is, once you open this, if you had set up a passphrase, so it would ask you to enter that passphrase, only then it would show you the contents for it. Then close the command line now and you can see there are two files created here. There's a .pub file and a file created here. So the thing is, you need to copy the contents of the .pub file, which is this one right here, right, the publisher document. Now I've already created, I've already have my key here. So let me just tell you what exactly is inside the publisher document. I'm going to open it with editor. You can open it with Notepad or any other application that is, letting you show the data. Then once this opens, yeah. So as you can see, this is my key right here, SSH, RSA, and many things. Now this is just one line since this editor won't let you have unlimited number of characters in one line. So it's putting the things in the second line. But as you can see, you have your SSH, RSA. So RSA is the encryption process, right? There are different type of encryption, and this is one type which we have right now, that is the RSA. So remember this, right? Now you can, the other thing to do is just copy this content here. Okay, then what you have to do is go to your add items, right? Go to your add items and enter this key here. Okay, so you have that with you. Then we have the management part, right? If you want to have some description for this, enable deletion protection, or if you want to have some scripts written so that on startup the particular script will run. Then if you have some metadata that you want to add, so if you click on add items here, then key one, value one. So basically what we did here, right? We have our SSH key one right here, right? So it would be better if you actually don't copy things here, right? And better yet, make a key pair value in the metadata. So what happens is that while you could have created the key from there too, it's better to store in metadata, because in metadata, all of the extra information about your instance is present there. So accessing your keys through metadata would be much easier. So what you can do is uh, just maybe write, just maybe write uh, key key one, okay, or maybe just write the the user of your local machine. So for me it is kit, and I would just paste the value here. Okay, so right, so like we have a user for our Windows, right? So the user for me is KIT, and the value is this. So I can move forward now with you know other dependencies or configurations. Now I'm gonna keep everything else as default and create the virtual machine. So once you have created the virtual machine, right, I won't be creating a new one for now, but once you have created your virtual machine, it would show you the virtual machine in the list of VMs, right? So it would come here, right? It would redirect you to this page, and in here it would start that you have deployed the the VM, and after some time it would tell you the status as tick that the instance is now running. Now let's say that you have not, set up the SSH keys while you were creating the instance. So then the next thing that you can do is scroll down inside your compute engine to metadata, right? In metadata, you can you can see there's metadata, there's SSH keys. Go to SSH keys, then click on edit, right? Then you can click on add items, then enter the key. So if you enter the key right here and click on save, then okay, so it's asking me to save the duplicate SSH key. Let's say that I want to save, right? So it's gonna save, and then it would take some time, I guess, right? So the thing is, once you have saved this, then it would create the username and key for you. Now you can see that I hadn't specified any username for me, right? I only just inserted the key here, but the username is already present here, right? So if you have created your key perfectly through the command line, then the Google Cloud would easily able to understand that who was the username for which the key was generated. So if you're not getting a username here, then that means you have done some error while any of the steps for creating the key, right? Then yeah, okay. So I'm gonna click on edit again because I already have duplicate keys. So I'm gonna remove the duplicates, right? Click on save again. So it's gonna save the edits that I did. Then coming back to the VM, right? Coming back to the VM now, yeah. So I have my SSH keys here. I also have an external IP address and internal one. So the external IP address is what we are going to use to access our website on the internet. Okay. And now the next thing to do here, after you set up and also configure your virtual machine to an extent, you have to go. Okay. Now you have to go to the, I would say, yeah, you have to go to the VPC settings, right? So again, go back to your dashboard, right? Go back to your dashboard. You have to go to your VPC networks, right? In the VPC networks, you will be given some options of firewall, right? So go to firewall. Now inside firewall, there you're going to see some, okay, it's taking lots of time. Okay, here you can see in my firewall, right? In my firewall, there are firewall rules right here, right? So what happens is that we have something called inbound and outbound rules, right? So security group acts as a firewall, which is what Google Cloud is calling itself, and your Google Cloud instance, inside your Google Cloud instance, to control the incoming and outgoing traffic. Now, to make things a little easier to understand, inbound means incoming traffic or incoming connections coming to your Google Cloud instance from anywhere across the internet. So for that, you have to add an inbound rule so that maybe external applications are able to connect to your instance. Now, outbound means outgoing connections from your Google Cloud instance to any other instance or any other machine over the internet, right? So when you type a particular URL, right, let's say www.google.com, So what happens is that this particular google.com is connected to a particular DNS, right? Which means that it is mapped to an IP address, and through that IP address it is able to understand that I have to connect to this server. So the browser asks for a connection to the particular server, then the server sends back information so that the user is able to see that information on the browser. So this is basically how things are happening on the internet. Okay, so what you have to do here is that you have to create a firewall rule, right? So that your Django application is also able to, connect or make a connection with your virtual machine. So you can see that I've already created one, right? You can see that allow Django here, and yeah, you can see here. So this might not be present for you, but the rest of them would be present for you. Okay. So create a firewall rule, right? Click on this, and inside there, what you have to do is, yeah, first thing is just name the rule, name it anything else like allow Django to, then description helps in connection to, oh, connection from Django to VM, right? Then if you want to have the logs on, keep them on, or it's off, let it be default, priority, let it be this, allow actions, and right. So in the targets tag, right, in the targets tag, what you have to do is, okay, well, yeah, if you want to leave this one also, then that is fine too. But the important thing would be to set in the source IPv4. So even in the example, you can see you can set up either all ranges or you can set up a particular one. So set up all ranges 0.0.0.0 slash, okay, slash 0, right? Set this, then there's no second filter here. Specific protocols and ports, yeah, it should be. So we're gonna go with TCP, and in the TCP we want to have 8000 because Django works on or connects on 8000. Then click on create. Okay, so once you click on create, uh, that particular, that particular firewall will be then listed in the all the firewalls that have been instantiated for the project, right? So you can see that here. Then again, go back to your virtual machine, right? Go back to your virtual machine that is inside compute engine, virtual machine instance. Right, so once you have done this also, you can say that you have now, set your, I would say set your VM properly, right? So you can see that we can now connect to the instance. So in this, click on open in browser window. So it would open a new window, right? And here, okay, here it's again taking a lot of time, right? So we have the connection being established right now. And once this has been established, you would see that uh, a terminal has now opened, right? You can see the terminal is now open and you're inside your VM. So you can see that if I type in Python 3 dash version, so there is already Python installed right here. So for now, I'm just going to exit out of it because we still have things to do. Now, before ending this video, I'm going to ask you to download some particular, right, some particular uh, softwares which would help us to make the process of transferring files and setting up the virtual machine, the code inside the virtual machine in a very smooth manner, right? So the first thing to do is install Putty, right? Install Putty, that is a free SSH telnet client, right? So as you saw that I had, uh, connected to my virtual machine through the browser, PuTTY helps you in connecting to your virtual machine and opening up the console, right? So it has a similar thing to do. If you don't want to use the browser, then you can use PuTTY. Then the next thing is PuTTyGen. So you need to have the PuTTyGen software too, right? Download the PuTTyGen software. And lastly, download WinSCP, right? Download WinSCP and install WinSCP on your local machine. So with these three, or for particularly Google Cloud, PuTTyGen and WinSCP, both of these are, I would say, both of these are pretty important if you want to have, a pretty easy way of handling files, transferring files, and setting your project inside your virtual machine. So I would be covering that in the second video. So let's meet. Hi guys. So coming back to where we left off. So now we're going to transfer our files to the VM and then set our code inside the VM. So for, starting off with this, the first thing you will need to have is the PuTTyGen, right? Okay, not exactly the right spelling. Then we should have the PuTTyGen, right? So open this. Now once you have opened this, click on load. Okay, also see here there's the RSA type, right? You can see the type of inscription is RSA. We also have EDDSA, SSH1 RSA, right? So we created the RSA one. Now the thing is that you need to go to the place where you had created your pub file, right? Through the SSH-keygen. So click on all files here so that it's showing you the pub file. Okay, click on this, click on open. Okay, so I think I have selected the wrong file. So click on all files, click on, yeah. Okay, don't take the .pub file, take the just file, right? Since two files were created. Click on open. Okay, it has now imported the foreign key. Click on open. Right, so you can see that the key comment is the person, right? And I have the fingerprint with me too. Now click on save private key. Yes. Then save this, in a place where you can access this, because with the help of this particular key, right, the PuTTY private key, we would be helping in connection of WinSCP to your virtual machine so that we can transfer our files, right? So name this as I would say name this as what? Okay, so music popularity private. Okay, this would be saved as a ppk file. Click on save. You can then close this. Then again go back and open the WinSCP, right? Open the WinSCP, and here WinSCP is going to open, and then again we would need to connect, right? We would need to connect. And okay, so it has already saved, right? It has already saved things. But if you want to create a new session, then click on new session, and in new session what you have to do is you have to type in hostname, username, password, and the port number is going to be same. So we're going to have the ppk file as a password, and the host is actually this right here. Copy this, right? Copy this and put that here, right? And the pass. Okay, so your username. So I talked about the username in the metadata part, right, where we had saved our key. So the username would be the username that was shown in the metadata part, which was kit for me, and it would be probably something for you too. Then in the password section, click on advanced, and the advanced would open up a pop-up. Then go to authentication. Here it's asking for the private key file, right? It again takes the private key file as a password. Then you go to the place or the directory where you had saved your private ppk file. Click on this, click open, click login. It's gonna authenticate and see if we have uh, the correct I would say the correct password and username for us, right? It's going to show you how much time has been, till you have logged. And then what you can do is on the left side, you have your local machine files. On the right side, you have your VM files. Now you can see that the owner, right? The owner is root for this particular folder, and for my side the owner is kit. So I'm a user inside my virtual machine. So if you want to have let's say if you want to have administrative access, then you need to maybe run the sudo command, or you need to change your owner, right? But the thing is, we won't have to do such things, because the first thing we are going to do is just drag and drop the files here, right? So if I would just drag, okay, just let me show you. If I, you know, what I can do is, okay, rather than this, let's say that I have to transfer this file right here. So I would drag and drop here, and you can see the file is now present inside it. So same thing I did for my code base. I took the my side and pasted it here. So with that, I was able to transfer my files to, right? And let's say that you don't want to have some files on your VM, so you can just select them and type in delete, and okay, right? Inside here you can see all I have all my requirements. If I want to delete this too, then I would delete, right? So even if I have to change something, let's say in requirement.txt I have to change something, I can double click on it and open an editor. If I have to make some changes, I can make some changes, right? And then click save and then close. Right, so I've transferred things up. Okay. And you can even see that I made some changes, so that changes were also transferred. Then once you have done that, you can close this, right? You can close this. I'm going to save it, right? So you can close this and again come to your browser, onto your console, and open a browser window, right? In the browser window, again, it's going to take some time to connect, and then it would log in into the VM, so you could make changes inside your VM or set things up in your VM. So you can see that we have the connection being established, right? Now I'm going to tell you about some of the Linux commands that would help you in setting things up, or help you in generally knowing more about what is happening in your VM. So as I talked about the sudo command, right? So we have the sudo command, which gives me the administrative rights. So basically what happens is that on to any command, we proceed with sudo. Basically, we have a command, okay, before even moving forward with that, and the things that you can see here is that I have an IPv4 address set up for me. I have the number of processes that are running right now, memory usage, percent of disk usage, right, and the system load. So till the time the system load is around 5, 6, 7, max 7, it's pretty okay. But after 8, 9, your website would be loading slowly, your refresh would be slow, or if you want to show results or show data, that would be slow, right? So at that point, it means either to have another VM initiated and have a load balancer between them, or upgrade to a better VM. Okay. So the thing is, you can see the user right now is loosely, right? But the user that we input in our WinSCP was a kid for me, but basically it was a different user, right? So we have to, okay, so the first command that I'm going to run is the ls-8 to see what all, what all files or folders or subdirectories we have with us. So the different colored ones are actually different subdirectories we have inside the music popularity loose leaf right here. If I type in pwd, I would be able to see in which directory I am currently. So if I cd and I'm inside my home directory, if I again type in this, so now you can see there is a Ubuntu directory, there's a loose leaf directory, there's a kit directory. So I'm going to go inside my kit directory because this was the user that we used when connecting the WinSCP to our machine, right? So if I go inside the this directory right here and type in this, so now you can see that I have my site folder which I had transferred, which is basically my code base only in the kit directory, right? So the thing is, let's move inside the my site directory, right? So you can see there's different folders and files right here. Again, pretty obvious. But again, talking about the sudo command, let's say that the requirement.txt file needs administrative rights to, open this file or access this file or make changes in this file. So what you type is the sudo command, then another command, right, which is nano, which opens up an editor for you, then requirements.txt, right? So you were able to open that. You have to move through the up and down right left keys here. You can't uh, type in, right? So you can use your cursor, but if you want to make some changes, you can make some changes, then control X to close the requirement.txt file or the editor, right? But since requirement.txt does not need administrative rights, so we can even exclude the sudo command and run this. Yeah, so let's say I made changes, right? I made changes in my any file. Then if I control X, it would say if I want to save my buffer or not. Press Y, then it would ask if I want to write the file name as requirement.txt only. Click enter. Okay, what happened? Okay, so I'm given the thing that error writing requirement.txt permission is denied. Okay, so that means I do need to run the sudo command here, right? So let's say that I have this right here, then I'm trying to make changes. So see, before I was not able to do that, but now I'm able to do that because with the help of sudo, we do get the administrative rights. Then I have the find function, the find command. Let's say I want to find requirement.txt. Okay, I spelled it wrong. Requirements. Okay, so it would tell me where exactly the requirement.txt is inside my directory. So since we are in the same directory where the requirement.txt is only showing me the file name, but if you were in a different directory, it would show you the subdirectory and then the file name. Okay. Then we have the free m, which tells you about the memory that you have, how much of it is being used, then the free and the available nums. Then we have the next command, that is df-h. Again, dot dash m dash h both are flags to be used, right? Then we can see that I have a file size of, the space of 9.6 gigabytes. We have used 2.9, available is this, use 30%. And for different disk spaces or fragmentations, you can see how much has been filled up and how much is available. Now, since we have moved forward with all of that, let's come to the most important, the meat of what we are going to do while configuring. Now you have your code with you right now, right? So the next command to run is this command right here, right? So that sudo apt-get update and all. Again, go back to your browser here, copy paste it, right? Copy paste it and run this. So what this will do is either it would update your pip, right? It would update your pip, or if there's no pip installed on your VM, then it would install the pip. Now since I have already done this, it would only show me that either it's updating or there's nothing to update, right? So run this command, just hit enter and it would run the command. This might take some time on your VM because your VM is not exactly the most powerful VM, right? So this might take some time to initiate and run all the processes. In between, it would also ask for your permission, so you would need to type in Y or N, right? So type in Y if you want to go forward with it. Actually, you have to go forward with it, so type in Y, right? So once that has been completed, your pip is also installed, so we can move forward with installing the requirements for your project, right? Whatever we have in our requirement.txt file. So we would run the command pip3 install dash r requirements.txt, right? We would hit enter and okay, I missed out the p. Okay, again, I had already set things up, so it is telling me that requirements are already satisfied. But for you, what you can do is, okay, actually for you, it would be starting to install all the applications and the dependencies for your Django project. And once that has been completed, it might show you some warnings about the path. Now that is happening because, right, so that is happening because we haven't set a virtual environment inside the VM. Okay, that is good practice to do so, but I have excluded that because we won't be actually I won't be working on this project after its completion. So if you were to make changes again and again, or you want to append more functionalities, then it's better to go forward with a virtual environment, create one, then install all your dependencies in that. Right. So again, let's say that you have done with this part too. Then again run python 3 manage.py migrate. Okay. So if there's some changes, then it would perform the necessary migrations. If there are no changes, it would tell you no migrations to apply. Then run the last command, which would instantiate the server. Right. So this is important to run on 8000 port. So it would check, have some system checks, and then it would start running your VM and your code base inside that, right? So now copy this, right? Copy this, paste it. Okay, not exactly paste it. Basically, what you can do is better yet, just click on this.
I don't have an answer for that. Is there something else I can help with?
Okay. My CD kind of took that as an initiative to talk about something. Anyways, and now, right, you have this. Okay, why is it showing me this? Yeah. So first of all, take the S out, then type in the port, and lastly the particular URL. Hit that and it would show you the page, right? Again, since we haven't submitted any data, we have submit the data. Then type in the data right here, right? And once you have submitted your data, then we can move forward with the prediction. Click on submit, and now you can see that the song will be not popular. So with the data that we have input for the song, right? So with this, you can see that now you can access your site from anywhere across the internet, right? And with this, we have also completed the third part, which was hosting our website onto Google platform using the App Engine.